What you are looking at right here is what I like to call page 1 of the test 7 review packet. We have 8 tests. This is part 1 of the test 7 review packet. Test 7 is in a couple weeks. I don't know. Look on your syllabus. You got the first day of school. Then you'll never know. You'll come in one day and it'll be like, all right, clear your desks for a test. Okay. So let's go through these one at a time. Problems 1 and 2 were crazy easy. Some people got arithmetic and geometric formulas mixed up, and that caused a pretty massive reduction in points. But geometric sequence is a sub n equals the first term, 7, times the common ratio, 2, raised to the n minus 1. Right? Arithmetic sequence, a sub n, is the first term, 7, plus the common difference, negative 2, times n minus 1, which, if you distribute the negative 2, you can get negative 2n plus 9. Yeah. So either one of those would have been accepted. Now, in number 3, we are not given either the first term or the common difference, but you can easily use subtraction. So 115 minus 190 results in negative 75. So your common difference should come out negative, right? Because the numbers are clearly decreasing. So you should get a negative common difference. And then divide that by 5, because that's how far apart the terms are, the 10th term and the 5th term. And you get a common difference of exactly negative 15. So your common difference is negative 15. So you have a sub n equals negative 15n. And so this is where I ask myself, okay, if I were to plug 5 in for n, for the 5th term, negative 15 times 5, that's negative 75. What would I have to do to the number negative 75 in order for the function to actually output 190? And that is add 265. 265 is not the first term, right? Plug 1 in, 250 is the first term. So had you done systems of equations and stuff, maybe you came up with the expression, the first term 250 plus the common difference negative 15 times n minus 1. Those are the same. And then finally, number 4 is similar to number 3, but with geometric instead. So if we divide these, you get 64 divided by 16 is 4. 27 divided by 3 is 9. And that is going to be r squared. Let me... A sub n is a1 times r to the n minus 1. So 16 thirds, or no, let's do the other one first. 64 27ths is a1 times r to the 4th, right? Because it's the 5th term. And 16 thirds is a1 times r to the 2nd, because it's the 3rd term. When we divide these, 64 27ths divided by 16 thirds is 4 ninths. A's cancel, and you get 4 minus 2 r squared. Technically, though not many people acknowledge this, you do get 2 solutions, a positive 2/3 and a negative 2/3. And did I give you enough information to know which one of those is actually correct? No. This totally could have been negative 2/3. Though I wasn't very picky, I didn't care which one you picked. So just for the sake of simplicity, let's just pretend the common ratio was 2/3. I really should have, That can also get you the right answer. Okay? So now we got to find out what the first term is. So what I would do is I would plug that in up here.
Wait, so you just threw it in?
Yeah.
But I thought that meant the second term, the symbol for it, not.
No. A sub. Yeah. A sub 2, subscripts. A sub 2 is the symbol for the second term. R is the common ratio. And that 2 up there means they're multiplying it times itself. Yeah, why would that notation all of a sudden change? Right? I mean, if you see a number written up here, it's an exponent no matter what. These subscripts are down, right? And that's just and subscripts aren't a mathematical concept at all. It's just a different way of naming things. Okay. So we get 16 thirds equals A1 times R squared, which is 4/9. So when we divide both sides, we end up with A1 being 12. Right? Or negative 12, depending on what you got. So your expression should be 12 times 2/3 to the n minus 1.
Well, you just multiply the 16 thirds by 9/4.
No, you multiply the 16 thirds by 9/4.
Yeah.
There you go. Some people came up with other expressions, and I did take the time to see if they were correct. And some people had some very creative things. I think some of you said, "Forget this whole geometric thing. I'm just going to find a pattern that fits." And so they had an expression. Powers of 2 in the numerator, powers of 3 in the denominator, just happened to come out geometric. So they lucked out.
I didn't know the equation how to do that, so I just tried to use it. I got pretty close.
Yeah, not bad. All right, any questions on the first 4? Sequence questions. The next 3 are all series, and you should identify immediately that this first one is an arithmetic series. The last 2 are geometric. Number 6 is a finite geometric series, whereas number 7 is an infinite geometric series. So, in order to add up all the numbers in a arithmetic series, you have to know how many numbers you're adding together, divided by 2, the first number in the list of numbers you're adding together, and the last number in the list of numbers you're adding together. So first of all, let's remind ourselves about what sigma notation actually means. We take this expression 2k plus 4, and I start by plugging what number into it? 5. So that's the first number. Then you plug what number in? 6. That's the second number. And you keep on adding new numbers, 7, 8, 9, 10, until you stop by plugging what number in? 70. So that's what that number 70 is. 70 is not the last number you're adding. It's the last number you plug in to generate a number that you're adding, right? How many total numbers? 1, 2. How many total numbers are we adding together here? 66, right? 70 minus 5 is what? 65. But that's calculating how far apart, how many distances between numbers there are. There's actually 66 numbers being added. Right, and that would be true if that bottom number was 1. So you're going to have 66 divided by 2 times the first term, which is 14, plus the last term, which is 144. And so you should get a final answer of 5,214. Kablam. Agreed?
Yeah.
Yeah. Number 6. This is 2 times 3 to the 8th, plus 2 times 3 to the 9th, plus 2 times 3 to the 10th, plus 2 plus 3 times 3 to the 11th, finally finishing with 2 times 3 to the 21st. How many total terms from this sequence are we adding together? 14. 21 minus 8 is 13. That's 14 total numbers. So the formula is going to be the first term, which is 2 times 3 to the 8th, whatever that is. It's huge. Times 1 minus r. What is the common ratio? 3. Right? What are you multiplying by each term to get the next term? So that's 3 raised to the 14th power divided by 1 minus 3. And what you should have gotten is 31,381,000,000 something. You could have just written it in scientific notation, or even your calculator's E notation. I'm not very picky. But it should have been, what is it, right around 31 billion, I believe. Big number. And then finally, number 7, just take the first term divided by 1 minus the common ratio r. The first term is not 4. you have to plug the number 1 in and find out that the first term is 4/3. The common ratio is 1/3. 4/3 divided by 2/3 is 2. So if you were to add together all infinity of the numbers from this series, you get 2. A lot of people got 6. Understandably.
You have to, for the top, for the numerator, you have to multiply it.
Huh? You just gotta find out what the first term is. You take this starting index number and plug it in. It comes out to 4/3.
It's not just.
Okay? A lot of people plugging, the wrong number in for R, just conceptually, clearly not really knowing what R is. So let's get this stuff figured out.
That one was to be like a 3, then you would just plug 3 in for K, and then that number would be.
So if this said, what is the sum from K equals 3 to infinity of 4 times 1/3 to the K, then yes, you would plug 3 in for K, and that would be the number that you put up here. Yep, but your common ratio is still 1/3. Yep. Good stuff.
What?